So we are looking at this system of equations with this initial condition. Everybody clear? Okay. So first we will solve for the eigenvalues, right? And when we do that, well, this we shall set this determinant equal to 0, right? Okay. So we have this, and then we got what? 10 minus lambda, and then minus negative of 4 times 9 equals what? 0. Everybody clear? Troy, are we good? Okay, so then we have lambda square. Let me just write in the same order as it was before, negative 20. Then you have what? Plus 2 lambda minus 10 what? Lambda again plus lambda squared, right? Then plus how much? 36 equals who? 0, right? So this will give us, okay, we have lambda squared, right? And then how many lambdas? We got negative 8 of them, right? And then to negative 20 plus 36 is 16. And then we have lambda minus 4 square equals 0, right? Everybody clear? Okay. So we have this, right? So 4 is a repeated eigen value, right? Everybody clear? Okay. So then what we do is 4, or rather you can write eigen 4 and 4. All right. And in this case, let's work on it. Okay, this is repeated, so we may check this here. That who knows, we might be able to get linearly independent eigenvectors. We haven't done much linear algebra in this course, so let's just wonder. All right. If we do or we don't. Okay. All right. So here, this will be what? 4, right? Okay, this is 9. It's negative 4, right? And this is 10 minus 4. And we put what? X1, okay, X2 equals who? 0, 0, right? Everybody fine? So we have negative 6. And here we got what? 6, right? Are we good? So you have a negative 6x1, right? Plus 9x2 equals 0. And the other one is negative 4 x1 plus 6 x2 equals 0, right? So what does this tell us? This tells us that in the first one it tells us 2x1 equals 3x2, right? In the second one also it tells us the same thing, right? So we don't have two linearly independent eigenvectors corresponding to this eigenvalue, right? Everybody clear? Okay, because if you look at this eigen vector right here, okay, then this can be written as, okay, so see, I can write x1 here, and x2 is what? 2 thirds x1, right? Everybody clear? So let's take x1 out. What we get then is 1 and this. So all the eigenvalues are what? Multiples of this vector, right? Everybody clear? Okay. Or if you want, you can multiply it by 3. So all the eigenvalues are multiples of this. Or, you can write them in many equivalent forms. Okay, say you can write this as 3 too, right? Are we good? Okay, very nice. So the trouble is, now we are remember this, in earlier cases we had gotten a lot, so it was good, it was easy to get two linearly independent eigenvectors, right? Or two linearly independent solutions. In here what happens? We have only one solution if I go in this route, right? Which is this vector multiplied by e to the 4t, right? Everybody good? Okay. So what we do here, okay? So in this case, what we are doing is this, that we are assuming, okay, or rather trying along the same lines as before, okay? So try x equals, okay, let's write a times e to the 4t plus bt times e to the 4t. Remember when you had repeated eigenvalues before, that's what had worked, right, Daniel? Okay, so let's just go and try, and of course this coefficient a here is a vector, right? 2 by 1. Okay, makes sense, Raphael? Okay, so if we are going to try this, what we will have to do, we have to, okay, substitute in what? This one, right? Makes sense? So see this here, if x is this, all right, then who is x prime? That's going to be here, that's going to be 4a, right? And now this a and b are constant, so we don't have to worry about those. So here I have e to, now here I'll use the multiplication rule, so this is gone, and then for the other one, what I will have then, simply 4 times that, right? Are we all fine on this? Everybody fine? Sir? Yeah, sure. See this here? I'm differentiating this because I'm going to substitute this in this differential equation. Okay? All right? Okay. And so this is x, so I'm computing x prime. E to the 4t, the derivative is 4 times e to the 4t, right? For this one, I'm using the product rule. So derivative of t is 1. Now I left t alone. E to the 4t, the derivative is 4 times all that, right? Very good, Mehdi. Okay, good. So what we have then is that we got this, and okay, let's leave it like this, okay? All right, are we fine on this? Let's leave it like this. So in order for, see, if this is a solution, then notice this. This is my left hand side, right, Rodney? Okay. And what is the right hand side? I got this matrix. I'll multiply that with this, right? Everybody fine? Okay. So this has to equal this times who? All these guys, right? Everybody fine? Okay. So then notice this. Here I have 4a b times what? E to the who? 4t, right? Everybody good? All right. And here I will have what? Let me just write it in detail. This e to the what? 4t plus t e to the 4t, right? Everybody fine on this? Okay. Is that good so far? All right. So now what we will have is, let's notice this here. This part here, okay? See, e to the 4t, e to the 4t, their coefficients have to match, right? So we are writing this, right? Are we clear? Then t e to the 4t here, and this guy times b, they have to match, right? Are we clear? Okay. So in other words, so here b has to be an eigenvector of this matrix, because see that's what it's telling us, isn't it? Right? Sorry, b has to be an eigenvector of this matrix corresponding to the value 4, right? And here is a, so we can find a that way. All right, Tree, are we good? Now notice this here. Here we are given that, in this case, remember, we were given that x as 0 is at 0 is how much? 1, negative 1, right? Okay. So if this is a solution, then who is x at 0? Who is x at 0? That is simply what? A, isn't it, right? Troya? Because if you substitute t equals 0, that is a 1, right? And who this is? This is a 0, right? Okay, everybody fine? So, how much is A then for this particular question? A equals this, right? Are we good? Okay. Now for B, all we have to do is we have to solve this equation, right? That's all we have to do, right? Okay, so let's solve this equation. A is 1, negative 1, right? Okay, are we good? Sir. No. Oh, I didn't jump to that. No, it was given, Mehdi. Given. Happy? Right. Okay. All right. Are we good now? Right. So then, let's see who that is. That's this, right? So notice this here. So I'm not jumping to anywhere. I'm just writing this value, right? Mehdi. Okay, good. So who is B then? B is negative 11, negative 14, right? Minus 4 times that guy. So we have negative 11 minus 4 is negative 15, and negative 14 plus 4 is negative 10, right? And notice this. This is an eigenvector as we noticed before, right? Okay, this is an eigenvector for 4. Okay, because right here we can see that this is a multiple of 3, 2, right? Isn't it? Are we good? So the solution, no, you can then do it in shortcut. Okay, all right. You don't have to. Okay, I'll tell you in a moment. Okay, all right. This is like we did it from scratch. Okay, and then I'll tell you how does that scratch work in the case of. Yeah, very good. So the solution of this initial value problem is what? X instead of 0, we'll put t here, right? Okay, equals. Okay, what was the initial condition? I forget now. What was that? 1, negative 1, right? Times e to the how much? 4 t, right? Then what we got? We got 5 times this times t times what? E to the 4t, right? Are we clear? So this is the solution for this initial value problem, right? Okay. Now in general, like you're not going to show this entire detail all the time, okay? So what you will do first is, everybody fine? And then we will do the question that you asked, together based on this, okay? So once we get these repeated eigenvalues, right? We will assume that that is a solution. All right, are we clear? Yeah, so we will assume that that is a solution, right? Are we clear on this? Okay. And then what we would do is, if it is given as an initial value problem, then we will know who A is, right? Are we good? Now, if it is not, then I can take A to be any vector, okay? All right. So once I have gotten my A, all right, what I will do is, remember, where did B come from? Where did B come from? B came from this, right over here, right? Are we clear? That is, your B was this coefficient matrix, right? The matrix that gave you the linear system, okay, times this guy, I don't know why I'm writing all that, minus 4 times who? the same vector again, right? So once you have determined A, your B will be determined, right, after that. Make sense? Okay. All right. So this is, or in other words, say you have, for instance, x prime equals px, okay, as a system, right? Okay. System like this, right? Oops. Are we good on this? Okay. So x prime equals px, okay, and then this is form of the solution because we have repeated eigenvalues, right? Everybody clear? So if initial condition is given, A will have to be that initial condition, and if the initial condition is not given, all right, we will take an arbitrary vector A, because then for the general solution we're just going to assign, values to these arbitrarily, and all right. So once I have assigned values to the vector A, B will be determined from that. In which manner? That we will go PA, am I clear? Minus whatever my lambda is, right? Everybody clear? And multiply that by A. Everybody good? And that will give you the solution, okay? So this is the shortcut that you obtained from the numerical illustration of the question that we had, okay? Everybody fine?